Alright, so we have the 2019 Victorian Physics paper, question 9. This is on elastic and inelastic collisions, so that is module 2, inquiry question number 3 for the New South Wales syllabus. We have a proton in an accelerator detector that collides head-on with a stationary alpha particle, as shown in this diagram here before, and also what happens to them after they collide here. After the collision, the alpha particle travels at a speed of 4 times 10 to the power of 6 meters per second. The proton rebounds at 6 times 10 to the power of 6, 6 times 10 to the power of 6 meters per second. Before we start the question, let's just say the original direction, so the direction towards the right is the positive direction of motion. So we have the negative direction of motion for the proton when it rebounds, and the alpha particle goes in the positive direction after collision. The question says, find the speed of the proton. Let's highlight that. Find the speed of the proton before collision, modeling the mass of alpha particle being 4 times the mass of a proton. Show your working, ignore relativistic effects. Okay. So, relativistic effects, for those who are in year 11, is talking about special relativity. Obviously, we haven't done special relativity yet in year 11 physics in New South Wales, so we don't have to worry about that. But let's look at how we can work this out. Now, when it comes to trying to find out the velocity of the system, we want to use the conservation of momentum law. Okay, because momentum is always conserved before and after, or the change in momentum is equal to 0 before and after a collision. So that's the formula we should be using to solve for it. So if I was to write out the formula, it would be M, we'll call it the proton, MP, UP for the proton, M alpha, U alpha equals to M P VP plus M alpha and V alpha. Okay, so we want to find UP. We know that the alpha particle has a velocity of 0. So that means this value that we have here is going to equal to 0. We know the mass, or we know the velocities here, and we also know the mass. Now, so to speak, in this question here, we don't actually know the exact mass of a proton, but we can do some ratios here. We do know that the proton is equivalent to 1 in mass, and the alpha particle has a mass equivalent to 4. So we're going to use 1 as the mass, and we're going to use 4 as the mass for the alpha particle. Okay, so what we can write down here is 1 times UP, that's what we want to find. That's equal to 0, equals to 1 multiplied by the velocity, so negative 6.0 times 10 to the power of 6 plus 4 times the overall velocity here, which is 4 times 10 to the power of 6, and that's a positive value there. So we'll just write that there. Okay, another inclusion we can probably write in this formula here, technically speaking, is we can equate the masses as 1m and 4m, so you could write it like that. Let's do it in that format. It doesn't really affect the overall calculations at the end of the day, but it'll kind of make sense later on because we're talking about the ratios here. Okay, so when we multiply everything together, we have 0.6 times 10 to the power of 6 times m plus 14. So 4 times 4 is 16 times power of 6. Whoops. Just need to rewrite that. Times m there. And then we have 1m multiplied by UP. Okay. So we can add these two values together now. and then we can round off to find what the value for UP is. Okay, so what I find as the initial velocity of the proton was positive. I think that's 1 million. So 1, 0, 2, 3, 4, 5, 6, 7. So if I just round that off, 1.0 times 10 to the power of 7 meters per second. That was the original velocity of the proton, and it was going towards the right-hand direction there. Okay, obviously what did we do with the m's? Well, obviously we added them together and then we cancelled out with the m on this side here. As I showed before, it's not actually that crucial in this calculation here. We could have just wrote it as 1, 1, and 4. But yeah, so that's why we could do it in the first place, because they just cancel out at the end. All right, so that's how you do the collision question for the protons and the alpha particle. This one's relatively straightforward. We're just looking at the conservation of momentum formula to find velocity. If you want more challenging ones, then you would have a look at assessing whether or not this collision was elastic or inelastic. Anyhow, if you found this video useful, like and subscribe, and I'll see you next time.